Hello everyone, in this video I will deal with the introduction of the communication system. So you are very well aware of the communication, right? So here I am standing and I am conveying information, so that means I am communicating with you guys. So communication means we will be having a source, we will be having a destination which is some distance away from the source, and we have to convey this information from source to destination. That means here I have source, here I have destination which is some distance away from the source. So now I have to transfer information from source to destination. That is communication. Okay, so it is a process of conveying information from one place to another, from source to destination. So what is the primary goal of the communication system? Primary goal of the communication system, it is to reproduce the replica of the message signal at the destination. That means at the source you are sending some message. So communication system, it has to reproduce the replica of that message signal. So suppose if you are transmitting this signal, at the receiver also you must have this signal. Okay, but at the receiver if you are going to get signal like this, that means your information of the signal is completely distorted. That means your communication system was not successful in reproducing the replica of the message signal. Okay, so this is the thing, or this is the primary goal of the communication system, that is to reproduce the message signal at the destination. So earlier, in our ancient times, people used beacon lights, they used fire, that is to communicate. Okay, earlier in the ancient times. Then they invented telegraphy, then came telephone, and now there are different modes of communication. Okay, so here let us consider analog signal and digital signal. You know what are analog signals and what are digital signals, right? So analog signal means sinusoidal signal, okay, cosine signal, sine signal, these are sinusoidal signals. These are nothing but the analog signals because they are continuous. Okay, they are continuous in time. That means at every instant of time you can see that there is some value. That is analog signal. Digital signal means it is a sequence of symbols. So we can represent like this. Okay, so this is something like 1, 0, 1, okay, 0. So these are your digital signals, sequence of symbols. So communication system, while transmitting this analog signal, it should transmit with certain degree of fidelity. Okay, remember this word, fidelity, for analog signals. Okay, with certain degree of fidelity it has to transmit the signal. When it comes to digital, the communication system has to transmit such signals with certain degree of accuracy. So when it comes to digital, it is accuracy. When it comes to analog, it is fidelity. Okay, so this is about the analog and digital signals. You know how to convert analog signal, that is to digital signal. You have seen the processes like sampling, quantizing and all. So we are going to convert the analog to digital signals. Okay, so now we will see the voice communication system. What happens in voice communication system? So here we have source. It can be your voice or it can be speech. Okay, from there it goes to input transducer. Then it goes to communication system. After that it goes to the output transducer. Then it goes to the destination. So normally in voice communication system, your input transducer will be microphone and output transducer will be loudspeaker. So what are these transducers? These are the devices that convert one form of energy into another form. So here what it converts your voice, that is to electrical signal. Output transducer, it converts electrical signal back to the form which is required, back to the required or the desired message form. That is a function of the output transducer. So here what happens, your input signal, it is converted to electrical signal, and here again electrical signal is converted back to your message form. Okay, this is all about your voice communication system. So next, when you consider communication system, there are three basic parts: transmitter, channel and receiver. Transmitter, channel and receiver. These are the three primary parts of the communication system. So here if you have source, from there it goes to transmitter, then you have channel, after that you have receiver. After that you have receiver. And then from that it goes to destination. Okay, so see here, we will see what happens at transmitter, what happens in channel, what happens at the receiver side. So what are the processes involved in each of these sections? What happens in receiver, transmitter and the channel. Okay, so here there is a source. That means here you have input signal. This transmitter, it processes this input signal, okay, and produces the transmitted signal here. Okay, transmitted signal which is suitable for the transmission over this channel. Okay, it converts this signal to the transmitted signal and this signal will be suitable for the transmission over this channel. This channel has its own characteristics. According to that, this transmitted signal should be there. Otherwise, it cannot be transmitted through that particular channel. So that work is done by the transmitter. So at the transmitter side, we have modulation, we have coding. Modulation, which we will be studying in the upcoming videos. So what are these modulations? Okay, for example, I will tell you, in continuous wave modulation, we will be having a sinusoidal carrier. That will be a very high frequency carrier. Its characteristics will be changed in accordance with the message signal. Okay, so that is your modulation. We will see what is the need of modulation. We will see different types of modulation in the next videos. So coding is also done at the transmitter side. Coding is also done at the transmitter side. But for long distance communication, even the amplification is necessary. For long distance communication, without amplifying you cannot transmit. So even amplification is necessary for such long distance communication. That is also done at the transmitter side. So these are at the transmitter side. After that, it will go through the channel. So channel, I said, it has its own characteristics. And here some noise or interference gets added in the channel. Okay, noise or interference gets added to the message signal. And here we are going to get the received signal. And this receiver, it performs the operations on the received signal. Now our main goal is to reproduce the replica of the message signal, right? Here already the noise is being added in the channel, but now we want to replicate this message signal here. Okay, but noise is added. So there will be some processes performed at the receiver side also, so that the signal which is same as the message signal will be reproduced here. Okay, so this channel, it can be wired channel, it can be a wireless channel. So that means your channels can be optical fiber, okay, optical fiber, it can be coaxial cable, it can be twisted pair of cables, it can be satellite, it can be free space, okay, it can be terrestrial microwaves. So these are the different types of channels, because it can be wired, it can be wireless too. Okay, so after that we have receiver here, we have receiver here. So what functions will be there? So see here, modulation and coding are done at the transmitter side. So the reverse signal processing should be done at the receiver side. That means demodulation, decoding will be done here. Okay, reverse process of these two. And see here, in the channel, because of this noise, interference and all, there will be some transmission loss in the channel. So for that, to compensate this channel loss, transmission loss, we will be having amplification done at the receiver side. Amplification. And also we have filtering. Okay, filtering. So these are the processes performed at the receiver side. After that, we will be getting the output signal and it is reaching the destination. So this is all about the transmitter, channel and the receiver. So now we will see what is this attenuation, what is this distortion interference and the noise. We will see the waveforms of that also. So there is a huge difference between the attenuation and the distortion. So some might think attenuation is same as distortion, but no, attenuation is not same as distortion. See, attenuation is nothing but it is the reduction in the strength of the signal. Reduction in the strength of the signal. That means amplitude can decrease, power can decrease, energy can decrease. But remember, in attenuation, shape of the waveform does not change. Shape of waveform does not change. That is in the attenuation. So, strength of the signal changes here. Okay, that is attenuation. See, suppose I am transmitting 1101. Okay, 1101. 1101. So, here distortion, we will see distortion first. Okay. So, you will have something like this. See, the wave shape of the waveform is changed here in case of distortion. And this distortion, distorted wave. And how this distortion occurs? It is nothing but it is the wave perturbations, right? Because of the imperfect response of the system. Imperfect response of system. Because of that, we have distortion. Here in distortion, shape of the waveform changes. But in attenuation, shape of the waveform does not change, but here there is reduction in the strength of the signal. Okay, and here the shape of the waveform changes. We have seen harmonic distortion and all, right? So harmonic distortion is also an example for this. Okay, so if we use some equalizers, okay, the effect of this distortion can be reduced. Distortion can be reduced or it can be removed. If we use equalizers, we should use equalizers to compensate this distortion. Next we will see what is this interference. This interference, it occurs due to the extraneous signals. Okay, so here your interference signal, it can look like this. Okay, this is your interference, because of interference. See, for example, you have radio broadcasting. Okay, so what happens, you have many radio receivers, or what happens is your radio receiver, it will be intercepting different signals. Okay, it will be intercepting different signals at the same time. Okay, so that causes interference. So now, can we avoid this or reduce this interference? Yes, it is using appropriate filtering. Appropriate filtering, it will be reducing the effect of the interference, because interference signals that will start occupying different frequency bands other than the desired signal. Okay, so means information you will be having different frequency bands, interference signals they will be occupying different frequency bands. Because of that, interference can be reduced, right? Yes, that is using the filtering. Next comes noise. This is how the noise looks like. Can you make out something with this because of noise? No, we cannot make out anything. Okay, so this is nothing but it is an undesired signal which is getting added, unwanted signal which is getting added in the channel. It may completely, it can destroy your signal. Okay, so partially or completely it can corrupt your signal. Which one? That is noise. Okay, so here we will see whether the noise is unavoidable or not in the communication system. Answer is no, it is not unavoidable. In every communication system we can see noise. For example, in every communication system we can see this thermal noise. Okay, in every communication system this is present. What is this thermal noise? See, at any temperature above the absolute zero, the thermal energy causes the microscopic particles to exhibit the random motion. So here there will be some charged particles now. So the random motion of the charged particles like electrons, it gives rise to random current or the voltage. Okay, random current or the voltage. So that is nothing but it is the noise, thermal noise, which is unavoidable. It is present in almost every communication system. There are other types of noise also, but this is the one which is present everywhere. That is thermal noise. Okay. The filtering, it can reduce the effect of the noise. Okay, it can reduce, but it cannot completely eliminate the noise. There are some noises which cannot be avoided. Okay, so this is all about the attenuation, distortion, interference and the noise. The primary resources in the communication system will be channel bandwidth and the transmitted power. So what is this transmitted power? It is nothing but it is the average power of the transmitted signal. What is this channel bandwidth? It is the range of frequencies allocated for the transmission of the signal. Okay, message signal or the information signal. Range of frequencies allocated. So these are the primary resources of the communication system. And by electrical means there are some limitations also, that is nothing but noise and the bandwidth. Okay, so every communication system, it has some finite bandwidth B, and think that if your signal, if it is changing rapidly with the time, that means it will be allocating or it will be having the wide, means it will be covering wide range of frequencies when it changes rapidly with the time. Okay, but here the communication system, it has finite bandwidth, and that limits the rate of signal variations. So bandwidth is one of the limitations. Next we will see this noise. See, we measure this noise relative to the information signal in terms of signal to noise ratio. If the signal to noise ratio is very high, okay, that means signal power to noise power. If the signal power is only very high, okay, the noise gets unnoticed. But if the signal to noise ratio is very less, then it introduces errors in digital communication system. It introduces errors, and there will be fidelity will be decreased. Fidelity will be degraded or decreased because of this low signal to noise ratio in the analog communication system. Okay, it degrades the fidelity. Which one? Noise degrades fidelity, and errors will be introduced in the digital communication system. In analog communication system, noise, it degrades the fidelity. Okay, this is all about this signal to noise ratio. And Shannon, he stated that the information transmission, it can never exceed channel capacity. This was stated by the Shannon. So there was a Shannon-Hartley law, okay, which was assuming the uniform distribution of the message signal, and they assume that the noise is random and it is Gaussian in nature. So after these two assumptions, they gave this formula: C is equal to B log 2 1 plus S by N. Okay, so this is the Shannon-Hartley law. Okay, so this is all about the limitations of the communication system. Here we will see different types of communication. So based on the mode we have three types. Based on the nature of the information signal we have two types of communication, and here the technique of transmission, okay, whether it is a baseband or whether it is the communication that is with the modulation. So depending upon the mode we have three types, that is one is simplex, next one is half duplex, another one is the full duplex. Simplex is nothing but it is unidirectional and these two remaining are bidirectional. For example, here if you have a sender, here if you have receiver. Okay, in simplex what happens is your sender can send data, receiver can receive data. Your receiver, he cannot send data and sender cannot receive data. So he only sends, he only receives. This happens in your simplex transmission. Okay, simplex communication, only this thing happens. So this is unidirectional. And remember, examples: television broadcasting, radio broadcasting, where you have a transmitter, this is a transmitter, you have the receivers, okay, you have the receivers. So this transmitter, okay, it will be sending information to multiple receivers. So this is your simplex, okay, and we can have keyboard to computer connections or computer to printer connections, these all are simplex. Okay, so these all are examples of the simplex. Next we will see half duplex. See, here again you have sender, here you have receiver. So this is bidirectional. That means your sender can send data, he can receive data also. The receiver side also they can receive data, they can send data also. But remember, in half duplex it will be only one at a time. That means now if it is sending data, he should be receiving data. But after some time, receiver can send data and sender can receive the data. So this is your half duplex. So example will be your walkie-talkie. Okay, that is when the one person is speaking, the other person has to wait till he completes his. Okay, so that is your example, walkie-talkie. This is bidirectional, right, but only one at a time. Next comes full duplex. Again you have a sender and a receiver, but here what happens is simultaneously they can send and receive data. So sender is sending data, here at the same time receiver can send data and sender can receive the data. So this is bidirectional. Okay, this is also bidirectional and this happens simultaneously. So example is your telephone. So if you call someone, what happens? At the same time, you can also say hello, the receiver, he can also say hello. Okay, so there is two-way communication there. So you can also say hello, he can also say hello at the same time. So that is, okay, your example, telephone. So this is all about the simplex, half duplex and the full duplex communication. Next we'll go for this type of, that is based on the nature of information signal, we have analog and digital. Once again in analog, we have continuous wave modulation, we have pulse modulation also. If the carrier signal, that is if the carrier signal is sinusoidal, then it is continuous wave modulation. But if it is the series of pulses, then we can say it is pulse modulation. So the different types of pulse modulation is pulse amplitude modulation, pulse width modulation and pulse position modulation. And continuous wave modulation, we have different types: amplitude modulation, frequency modulation and the phase modulation. We will be studying this in detail in the next videos. So next is your digital modulation. Here you have pulse code modulation, delta modulation, adaptive delta modulation. So these are the different types of communication, that is analog communication and the digital communication. Next comes the technique of transmission, that is one is baseband transmission and another one is a transmission that is with the modulation. So baseband transmission means the information signal or the message signal, it will be transmitted as it is. Okay, it will be transmitted as it is. See, baseband signal is nothing but it is a low pass signal. This is very important. So this is a low pass signal. Okay, here if we see the spectrum of this baseband signal, it will be centered at 0. It will be centered at 0. This is the spectrum of the low pass signal. And if a spectrum, if it is centered at a frequency other than 0, or if it is centered at the carrier frequency, then it will be your band pass. Okay, band pass. That means it happens only with the modulation. So that is here you are going to get something like this. This is your minus Fc, this is your Fc. Okay, so this is your band pass. This is the base band. It is centered at 0. So information here, it is sent as it is. That is in the case of base band. But with modulation means we will discuss the different types of technique. We will see how the frequency translation occurs also. Okay, so that is with modulation. This is the band pass. This is band pass. This is your base band. So this is the different techniques of transmission.